Okay. So welcome back to the computer science session for Source. A couple of quick reminders. There will be a award ceremony for outstanding oral presentation of Source on Thursday, June 2nd in the Cirque Ballroom. And there's going to be great desserts as well as just a celebration of Source this year. So feel free to take and join us for that event. You don't want to take and drive over from Seattle. You can also join us for the live stream of that event as well, or the webinar. A reminder that this room is streaming through Zoom right now. So we are doing that so that students, faculty, and staff at our other campuses and online can attend. And we want to thank you to both of our presenters for attending today. So with that, our next presenter is Bradley Reeves, who is going to be talking about Protego, a Python package for SQL injection detection. Nice play on words there.
All right, so good afternoon, everyone. It's great to see your faces again. So my name is Bradley Reeves. I'm a graduate student in the computer science department here at CWU. And today we're going to be talking a little bit about my project. It's called Protego, and it is an application for SQL injection detection. I decided that instead of tearing through these 31 slides in the next 10 minutes, that I would just go ahead and jump straight into the demo. But real quick, I kind of want to unpack what SQL injection detection kind of means a little bit. So SQL, we'll start with SQL. It is an ANSI standard language for communicating with the database or for performing operations on a database. So some of the operations you might be familiar with are things like reading data from a database, inserting data into a database, updating data, and of course, deleting data. You can do more advanced functions too, but that's what are the most common operations. SQL injection is when you interact with an application, SQL statements are getting generated by the backend pretty much constantly and being sent to the database to execute an operation. SQL injection is when attackers or somebody malicious may try to modify that SQL statement that gets sent to the database somehow. There's several different ways to inject your own SQL. And then detection, SQL injection detection, we're hoping to actually catch this before the statement gets executed against the database. That way we can decide how to handle that payload or that string that gets entered on the form. So without further ado, I'll go ahead and jump straight into the demo, and I will kind of explain some of these things as I go along. All right. All right, so the application is just a web application that we have here. So right now I'm in the sign on page. So I'll go ahead and enter my information here. All right, now when I hit sign in, this is just a good example of kind of how applications interact with the database. A SQL statement is going to get generated on the back end that's going to say something like select all from users, which users would be the table where email address equals this protego.contact and password equals what I typed in there. And if the database finds a hit on that match, then it'll say, okay, this user is good, and it'll authenticate you and allow you to log into the database. So that's just a quick example. So this is just the basic home page. All the magic really happens in the workspace here. So it does come with a couple of API endpoints. So in order to actually use those endpoints, you're going to need to generate an API token, which you will use for authentication. But what I really want to kind of jump into here is creating machine learning models. That's all what we're here for and what we care about. So you can see that I have some models already here created, but I'll go ahead and demonstrate creating a new model. And basically all this is going to do is instantiate that model. That model is not going to be trained or anything like that. It's going to be pretty much useless after you first create it. So you can see here, there's a so-called paradigm field. And this is going to be online or batch. So batch is kind of like what you traditionally think of in machine learning, meaning you're going to train all of the samples at once. Online is a little bit of a different paradigm where models can actually be trained incrementally. So you can train a model with some set of data. And then as you receive new data, you can basically update that model's parameters with the new data without having to completely retrain it from scratch. So I'll just select one here for the demo. And then you'll see within batch and online, you have about 6 different algorithms that you can choose from. So I'm just going to go ahead and go with a basic perceptron for now. And on the back end here, if you're familiar with any Python packages, it's just using the scikit-learn package for the batch, and then it's using a program called River for the online models. So when you create the model, or when you go to create the model, you're going to see all the parameters here, and it will actually initialize with kind of the default parameters provided by the package. So I'm just going to give this a name here. And then if you want to read more into what these parameters are, there is some documentation in the website, but there's also this button here where it brings you straight to what these parameters mean. Okay, so I'm just going to leave it with the default parameters here for now. Gave it a name and going to save that. So now we can see my model here. And as you can imagine, this can probably get pretty convoluted as you create more models. So if you're experimenting with like 2 or 3 perceptrons and you want to check what parameters you use to create that model, you can click this little settings button here and it'll show you all of the hyperparameters that you passed over. Okay, but like I mentioned, the model's pretty much useless at this point. So I have this review payloads tab here. And this is basically all the training data or the testing data, whatever data is collected through maybe your third-party application or samples that you've just added here yourself. This page is good. So if you want to come through and review samples, you can change maybe the classification on them. But yeah, this is where the samples are. And you'll notice that they each have their own ID. So when you go to train the model, you're going to select the model that you just created. And then this payload ID start and end are those IDs that I just showed you. So I think in the website right now, I have about 120,000 samples or so. So I'm just going to say from 0 to 100,000. And hopefully this doesn't take too long to train because it's a perceptron. It shouldn't be long. So there's this option here too. You can remove the payloads from the system if you want to. I'm just going to say no for now. And then you're going to train and then you're going to wait. So it's sending a request to the back end of the application. It's training the model and then it's going to send you some response depending on how that goes. Okay, so it says model trained successfully. So we didn't run into any issues there. One way to test the model is you can come to this page. And we're going to do this one we just trained. And so you can train with a single sample or batch. So if you want to do a batch, let's say I'll start at the next sample after the ones that I trained on. And then I'm just going to do like, there's not that many samples, but I just want to make sure I include everything. So if you hit test, and it should be testing on approximately 20,000 samples right now. So, okay, that's okay. We have about a 96% accuracy there. Now, what's also kind of cool is you can test on a single sample here. So if I type in, say, my name, we know that should be okay. well, it's going to come back and say that's benign, which is nice. But if I'm doing something more nefarious, like maybe something like this, and then let's end that and comment out anything else that might come after that. Oh, it's going to come back malicious. So you can actually call these using the API from maybe your own personal application. And I'll show you how to do that. There's documentation here that shows you how, gives you the name of the endpoints, the parameters that you want to send with the request, and then kind of what some of the response codes can be. I've done these. Unfortunately, I don't have a tool right now to do this, but I added some of them to my presentation here. And if you want this presentation, just reach out to me. I'll send it to you. Don't know if it'll go from that side. Awesome. So this is a tool called Postman, and basically it's simulating hitting one of those endpoints inside my web application. So you can see I got the URL here. This is just my group number 1. So what I'm sending it is my payload here, so we can see that that is a malicious sample. We're not passing a classification because we don't know yet at this point. And the created by is just going to be like what it's going to save in the database, like it was created by this user or this application or whatever. So once you have your body done, you'll have to also authenticate using one of those API tokens that I mentioned earlier. You're going to send this request to the Protego web application, and it's going to return this response, 200, which is a good response. And it's going to tell you that that sample is indeed malicious. So if you called this from your own personal web application, if you were using Protego, you can take that response and then decide what you want to do with it afterwards. So if you want to let that proceed, then go ahead. If you want to log it somewhere for people to analyze, that's also good. And then here's the same thing, but just showing a benign sample. And so similar to how I did the test single sample in the payload or in the web application, I'm just sending Bradley Reeves over, and it's going to return a benign response. So you can tell that, okay, that payload is not malicious. We can let them proceed as intended. And yeah, I suppose that's about it. Thank you very much. And we'll take questions for the next 5 minutes or so. Charles. So yeah, that's why this works with, it's a relatively easy problem. There's been lots of papers, I've seen 5 or 6, where they kind of try to tackle this problem, and it's pretty obvious, right? Because SQL is such strict syntax, it's like pretty easy for the machine learning algorithm to tell whether it's benign or malicious just from the fact that it has SQL code in it. But they can get pretty crafty with the different types of like payloads they'll send through. And typically when these types of attacks happen, they'll send through, you know, like thousands of requests all at once in a really short, rapid fire period of time. Which is why Dr. Andonie and I discussed incorporating some of the online algorithms, because if you're just getting a ton of benign samples at once, and then you get a malicious sample, it's not going to really know how to react to that. Whereas if it's an online algorithm and it's constantly being updated, the training parameters, then hopefully the idea is that it will adapt to those new samples that it's seeing. Yeah. Yes, Alex. So honestly, that was probably one of the most difficult parts about this project. There is no standard data set out there for this. I collected any sample that I could find basically on the internet, and there were a few like GitHub repositories. If you've heard of Kaggle, which is like this data science platform. I found a couple data sets from there also, but I actually generated a bulk of the data myself. So if you've ever heard of SQL Map, it's a like Kali Linux tool that you can use to actually perform SQL injection attacks. So what I did was I attacked a website that I already owned, and then I just logged everything that it was receiving. So yeah, that's how I got the data set. Yeah. Mm-hmm. Yeah, and he's an advisor as well, and he's had students work on similar projects. I've read papers from there. Yeah. Thank you all.
I couldn't get it to work. Like for you? Do you want me to? Okay. Okay, we'll start again in 1 minute. A reminder that there will be one more day of source presentations tomorrow in person. These also will be streamed via webinar. So if you're like Alex, you can listen to some of those as you are driving around tomorrow. In addition, especially in CS, there was several sessions that were pre-recorded and are available online. So you can take and visit the source website in order to take and get access to those presentations. There will be an award for outstanding oral presentation and awards for other source presentations given out on June 2nd. We promise you'll have good desserts. That's the thing that we are promising right now. And a reminder that we are live streaming this through a webinar and it is being recorded. So with that, our next presenter is Alex Worland. And Alex is going to take and talk about the visualization of decision trees based on general line coordinates to support explainable models. Take it away.
All right, thank you. Sounds like everyone can hear me okay. Hi, my name is Alex. Like I was just introduced, I'm going to be talking a little bit about visualizing decision trees today. So just briefly, what we're going to go over here, I'm going to introduce myself just a tiny bit, go over the goals sought out by this project, little background terminology, explanation of the method and algorithm that we're using, and a example. All right, so tiny bit information about your presenter. My name is Alex Worland. I use she, her pronouns. I'm a post-bac student here, senior, pursuing a Bachelor of Science in Computer Science. Obviously, having previously earned a music degree back in 2017. And for this project, my mentor was Dr. Boris Kovalerchuk, and he's a professor of computer science at the Central Washington University Department of Computer Science. Okay, cool. So overall, our goal was to use the concept of shifted paired coordinates to represent visually decision trees. And I'm going to explain what both of those are in just a second here if anyone's unfamiliar. When we do this, we can visually interpret the performance of the decision tree using this SBC method. And the kind of underlying motivation here is to support domain experts in their kind of interpretation of decision trees that they build, because they are going to know more about their own data than we are as computer scientists working on the visualization. So we want to make sure that they have as many tools as they can in order to accomplish that. So real quickly, a decision tree is a kind of a collection of rules that are kind of applied sequentially in order to find a kind of an output, a classification. So the one I kind of built here is just some random weather data that kind of tells you what kind of clothing you want to wear that day. So these are pretty interpretable visually. However, it shows difficulty in showing data passing through them, especially for really large data sets. They can kind of get overwhelmed with the amount of data. And the other technique that I mentioned earlier was shifted paired coordinates, which sometimes I'll refer to as SPC. It's a form of general line coordinates, which builds a series of these two-dimensional plots out of n-dimensional data. So this is a way to reduce the complexity in viewing data, but it's lossless, and that's a big deal when it comes to data visualization, especially for large data sets. On the right, we can kind of see an example. I apologize to any meteorologists seeing this. This was just random weather data that I just came up with. And so we can see on the bottom right that we've really simplified the data set in how it's being visualized. And so the drawback here, though, is that it's only a linear visualization. It doesn't really show us a collection of decisions and how a decision tree could be adapted to this. And so our method that we developed, which we call SPC-DT for shifted paired coordinates decision tree, I'm going to explain a little bit what the algorithm does. And so the first step is that we need a decision tree model pre-trained. We don't do any of the decision tree model training. That's been taken care of. But what we want is the output, which is kind of what we can see in this top right picture here, that we have a series of rules that we can kind of follow to eventually find out, in this case, if a tumor is cancerous or non-cancerous. And so once we have the tree, we can kind of we have to choose which attributes to pair up. And that's not always a simple task. So our kind of solution to this was to choose attributes that appear in close proximity in the decision tree. And then from there, we kind of build our Cartesian plots. We kind of arrange them. Well, I'll talk about arrangement in just a second here, but we kind of apply the decision tree to these plots that we've built. On top of these plots, we then draw rectangles representing kind of the decision zones that the decision tree has come up with, whether it's a classification zone or maybe a zone that says that a classification can't occur yet, so it has to go on to the next. Then from there, once we have the visualization, we can run data through it, and a domain expert would be able to interactively modify this visualization. And so there's a handful of ways that they can do this. The first being rearranging these plots. They can change the location of where these plots occur, and that alone can really help the visualization process. We can change the class color for classification zones. We can negate, swap axes, coordinate axes, and attributes themselves. We can draw a rectangle on top of these already drawn rectangles to condense all the points within them by class into a single point, which loses information, but makes the visualization a little less overwhelming. And then they could also adjust the thresholds themselves within these plots themselves. And I will show all of those in just a moment here. So we're going to look at an example of the Wisconsin breast cancer data set, which I'm sure has been mentioned a couple times already today. 699 instances of 10 attributes and a class for either a benign or a malignant tumor. So these are kind of just measurements made on the tumor, on the cells, and a domain expert has labeled this as a benign or a malignant tumor. So when we first load up the program and don't adjust anything at all, it's kind of a mess. So we can see here that points are really difficult to trace. We can't really tell which case leads where. We can kind of see where they end up, but we can't really trace back to where they started, and vice versa. Additionally, a little bit more information about this visualization itself. Red is for malignant, green is for benign, and these shades of gray kind of indicate that all points within a shade of gray go to the same destination plot. And so as the person visualizing this, they're going to be thinking, what can I do to make this a little better? And so the first thought is going to be moving these plots around. And so you can move these anywhere, moving them in such a way that they're kind of distinct from each other, making sure that these lines are overlapping a lot less. As we can already see, it improves pretty significantly, but there's still this problematic section here where it's still pretty much a mess. You can't really tell what is going on. And so a way to fix that is to apply our kind of ideas of negation and swapping of vertical, horizontal, and just attributes in general. So we can kind of reposition the plots and the data within them in a lossless, reversible way that really allows us to better see the lines and how they're not overlapping. They're a little bit more traceable. And so, and now we can kind of see without that little box around. So once we have our plots in the right place and they're swapped and negated, so on, we can kind of start playing around with how the decision tree itself is being shown. We can see that the points have been condensed in the gray areas. We can see that the color has been kind of shifted in the colorful zones, darkness being that these rules are a little stronger, more cases pass through or end up into them, and the opposite is true for the lighter colors, which is really important in identifying high risk, or like in high risk circumstances. And the last kind of thing that I'll mention is that these thresholds can be adjusted kind of in real time, and we can see the real time effect that these adjustments have on the accuracy of the decision tree, seen here in the on the left there. So I'll let that play just for a little second so we can kind of see how that changes things in the confusion matrix. Okay. And that concludes the presentation here. I would love to answer any questions that anybody has. Yeah. So the decision trees, at least for this example, were generated using the ID3 algorithm. Yeah, one of the algorithms. Yes. I believe so. That wasn't actually something that I had considered while doing this. It was a pretty binary tree focused. So I would probably need a little bit of time to think about if there are any. Yeah, I can kind of imagine instead of maybe a vertical axis being divided into two zones, it could be into three or into n kind of zones, each of which leading to a different plot. Yeah. Yeah, I mean, I suppose it would depend on which kind of maybe optimal parameters we're thinking of as far as if it's tree size or maybe the amount of cases that the tree has. but that's an interesting idea that in its current form is not. Yeah, exactly. Any other questions? We did not. So, oh sure, yeah. So we were just asked if we ran this with like a random forest. Is that, yeah, okay. We did not. We mostly just used either ID3, maybe even C45, just single tree generation. I think a random forest would be a really interesting addition, and that would be definitely a road to follow. Yeah.
Can you actually download this application anywhere and play around with it?
Let's see. Yes, it is on my personal GitHub. It needs to be moved to a more, maybe a more organizational for the CWU research GitHub, but it does exist. It's trying to think what types of requirements. It's a Visual Studio project, so it would need to be on Windows. Yeah, for sure. Any other questions?
I will point out that we try to take and archive all source presentations on the CWU library. Through that is we try to take and archive everything to allow for long-term access. Something I normally do that I should have done earlier as well is we had 3 awesome presenters here today. Any compliments for our speakers? Come on. Compliments for our speakers. You can do it. We did questions. Compliments, faculty members.
Because it's strange for me to ask questions. Basically, the major difference this work relative to the traditional visualization of decision tree, because they do not show individual cases. So you do not see the distribution of cases. So you can trace one particular case. And that's the major advantage. You can see the distribution and you can change the tree because you can see cases around the edges. For example, green and red cases. So like Alex shown that you can adjust and make a decision tree more reliable, more meaningful for the user.
Yeah, that's a nice compliment. I also really felt like presenting everyone that I had a chance to see really did a nice job of making it accessible and something that even a generalized audience would be able to get something from. And Rose shares that this is the most impressive graphs that they have ever seen. So, right. It's always worth ending. You worked so hard on this. We don't just want to end on like questions of like, why? Yeah. So we want to end also saying thank you for your hard work. And we hope you all continue to take and look at the presentations over these next couple of days. Thank you all very much.